Hi class! In this video I'm going to cover chapter 6.1 and 6.2, how to solve systems of linear equations that have two variables and also three variables. So first we'll look at two linear equations. When we have two equations and two unknowns, those unknowns being x and y, the graphs look like two lines. Those two lines can do one of three things. The first thing is the two lines can be parallel. And when we have two parallel lines, there are no solutions to the system of equations because the two lines never cross. The second situation is that you could have one solution to the system of equations, and that one solution will look like a point where the two lines cross. And the third situation could be if the two lines were actually the same line. So in that case, it's said that the system of equations has infinitely many solutions. So first I'm going to show you the steps of using the elimination method to solve for that point where the two lines cross, and then we'll try an example. First, the goal is to eliminate one of the variables. We do this by looking at the coefficient. We want the coefficient in front of either variable to be the same but opposite signs. And we can get this by multiplying through by a constant or multiplying through the equation by the same number. Doing that will not change the equation itself. It won't change where the line lies on the graph. It will only change the coefficients. Next, we add or combine like terms, the two equations, and by doing that, one variable will cancel. Lastly, we solve for the variable that is left and use substitution to get the second variable. So in my first example, I have two equations and two unknowns, those unknowns being x and y. I want to find where the two lines cross, if they do cross. They could be two parallel lines or they could be the same line. Let's try eliminating a variable. The first thing I'm going to do is I'm going to multiply through this second equation by a -2. That will give me positive 2y, and when I add down, the y's will cancel. So I'm going to multiply every single term by -2. So bringing over 4x minus 2y equals 4. My second equation is -4x plus 2y equals -16, and I'll add down. My x's are also going to cancel because 4x minus 4x is 0. -2y plus 2y is 0, so on the left hand side I have 0. On the right hand side I have 4 minus 16, which is -12. Now I can look at this statement and say, does 0 ever equal -12? No, it doesn't. And that means that there is no solution. And as we saw before, when there is no solution, it's an inconsistent system, and it means that these are two parallel lines. So when you get a true statement, it means all solutions. When you get a statement that's false, it means there are no solutions. In 6.2, we're going to be solving systems with three variables using the elimination method. Those three variables are going to be x, y, and z. So instead of a two-dimensional plane of x and y, you're actually going to have a three-dimensional plane of x, y, and z. Our goal in solving these three systems is going to be to eliminate a variable. We're going to multiply through by a constant or a number. We're going to add two equations at a time to eliminate either x, y, or z. And then we're going to solve two equations and two unknowns. So let's look at an example. So here I have three equations and three unknowns. I want to decide which variable to eliminate. So I'm going to go for the easiest one, and I'm looking at the z's here in equations 1 and 2, and it looks like if I add down, the z's will cancel. So I'm going to add 3x plus 3x, which is 6x, -2y plus y, which is minus 1y, and positive z plus negative z, which is 0, and that equals 6 minus 4, which is 2. So that's equation 1 and 2. So I'd like to eliminate the z again when either adding equation 1 and 3 together or adding equation 2 and 3 together. I notice that if I multiply equation 1 times 2, I'll have a positive 2z and a negative 2z, and that goes to 0. So I'm going to multiply through the first equation by 2. That gives me 6x minus 4y plus 2z, and that equals 12. And I'll bring down equation number 3, which is negative x plus 2y minus 2z, and that equals negative 8. So I can eliminate the z's when I add down, and 6x minus x is a 5x minus 2y, and that gives me a positive 4. So now I have 2 equations and 2 unknowns, and I can use the elimination method again to eliminate a variable. I think I'm going to eliminate the y's by multiplying through by a negative 2. Then I'll have a positive 2y, and when I add down, they'll go to 0. So that gives me negative 12x plus 2y when I'm multiplying through, and that equals a negative 4. So then again, adding down, I have negative 7x. The y's cancel, and that gives me 0, or dividing by negative 7, x equals 0. Now I can plug that 0 into either equation, this one or the one up above, to solve for y. So where I see x, I'm going to plug in a 0 minus 2y, and that equals 4. That goes to 0, and I get y equals negative 2. So I have my x value and my y value, and then I just plug those two into any of these 3 equations to get z. I think I'll plug them into the first equation. So I have 3 times x, which is 0, minus 2 times y, which is negative 2, plus z, and that equals 6. So 3 times 0 is 0. Negative 2 times negative 2 is a positive 4, plus z equals 6, and subtracting 4 from both sides gives me z equals a positive 2. So that means that the point where all 3 lines cross is z equals 2, x equals 0, and y equals negative 2. You can put a box around each one like this, or even better, write it in point notation 0, negative 2, 2. So watch this video again just to get the method, and then try solving it on your own.